Assalamualaikum and greetings ladies and gentlemen. I am Damia Iwani, a master student from University Technology Mara, Malaysia, and today I will share my project entitled Two-Dimensional Geometric Morphometric Analysis of Frontal Sinus using a skull radiograph for sexual dimorphism among Malaysian population. This study is in the field of forensic anthropology where they involve with the identification and examination of human skeletal remains. So when any disaster happens, such as fire tragedy or plane crash, so the victims of the incident might be found skeletonized, and the visual recognition, such as the facial recognition and fingerprint, might be impossible as there is only bone left to be analyzed for the identification. So this is where the forensic anthropologists will be involved, where they will establish the identity of that unknown individual via analysis of the bone. In the identification process, forensic anthropologists will establish four biological profiles, which are ancestry, age, stature, and sex. In this study, we focus to the sex profile as it is the first profile to be investigated by the forensic anthropologists. Currently, there are three main research gaps in forensic anthropology investigation in Malaysia. So the first one is related to the method used for identification. Generally, there are two methods used for identification process, which are conventional method and geometric morphometric method. However, there is disadvantages of using conventional method. So basically, conventional method use calipers to estimate the size of the bone via measuring the linear distance, such as the length, height, and also the width of the bone. So this method has poor reliability of using linear distance measurement. It also has limitation in shape visualization, and at last, it needs to be measured on the bone, which makes it time-consuming. Hence, in this study, we use 2D geometric morphometric method. So this method, instead of using linear distance measurement, it uses the landmark coordinates to outline the bone shape. So this method has better reliability of using landmark coordinates. It allows the shape visualization and shape measurement, and at last, it can be done on a radiograph, which makes it cost-effective. So the second problem is lack of frontal sinus database. So the database of other bones such as the skull and long bone database is commonly available, but this is not true for frontal sinus. Besides, the long bone and also the skull are commonly damaged in recovered skeletal remains. Therefore, they may not be suitable for the sex estimation. This eventually creating a need to look for other alternatives such as a frontal sinus for sex estimation. So frontal sinus is located within our frontal bone. Frontal sinus has a characteristic of a strong resistance to trauma, which make it well preserved in any catastrophe or mass fatality incidents. The third research gap is lack database of Malaysian population. Unlike the skull bone, the usage of the frontal sinus for developing biological profile in Malaysia is not available, and the study of the frontal sinus morphology among Malaysians itself is not yet present so far. Hence, in this study, we evaluated the sexual dimorphism of frontal sinus among Malaysians using 2D geometric morphometric method. This is the ethical approval from UMMC as we collected the radiograph from the hospital. In this study, we have collected around 453 of lateral skull radiographs that meet our inclusion and exclusion criteria. So we include cases of male and female of only Malaysian population, and it must be a good quality radiograph. We exclude any cases of sinus pathology, maxillofacial fracture, as well as non-Malaysian cases. After that, we input the radiograph into the TPS T2 software for landmark acquisition. Video on the right panel showing the application of 8 landmarks outlining the frontal sinus shape. This is the description of 8 landmarks outlining the frontal sinus. Geometric morphometric analysis, including GPA, PCA, MANOVA, and DFA, was then conducted using morphology software. After that, we got to visualize the frontal sinus and data analysis according to male and female sex group. This is the result for generalized prosthesis analysis. So GPA was performed to eliminate any non-shape variation in the sample via translation, rotation, and rescaling process. So the result from the GPA shows the mean shape of the lateral frontal sinus. So the blue dots representing the mean landmark and the small black dots representing the landmark of individual from the sample. Next, PCA was performed to visualize the shape variation across the sample in form of wireframe diagram and also histogram. So from the histogram below, we can see that there is a 12 pieces, 12 principal components that are responsible for the total frontal sinus shape variation. And the first 3 pieces contribute the most for the frontal sinus variation. So the diagram, the wireframe diagram on the right panels is to show how the frontal sinus shape in each species, PC1, PC2, and PC3 differs from the mean shape of the frontal sinus. So the dark blue line representing the shape of each species, and the light blue line representing the mean shape of the frontal sinus. Rupes's maneuver was performed to evaluate the differences in terms of central size and shape of the frontal sinus among the sex group. So from the table below, we can see that there is a significant difference in terms of central size and shape of the frontal sinus between male and female sex group. DFA was performed to assess the classification accuracy of the sample into the sex group. So from the table and graph below, we can see that this 2D geometric morphometric analysis of the frontal sinus able to correctly classify around 78% of male and around 82% of females into their respective group, with average sex classification accuracy of 80.6%. This radiograph is to visualize the frontal sinus shape variation between male and female sex group. So from this radiograph, we can see that the male frontal sinus shows a wider shape and female tend to demonstrate a narrower shape. For the discussion, our study found that there was significant difference in the sexual dimorphism between frontal sinus of male and female when using 2D geometric morphometric method. So when comparing to other study in terms of central size, the Iraq population shows a significant difference in the frontal sinus size as well. However, in terms of shape, there is a scarcity of reports on the significance of the frontal sinus shape difference, hence limited the discussion for the shape section. Our study demonstrated around 80.6% of the sex classification accuracy when using a 2D geometric morphometric method of the frontal sinus. So this result is comparable to the study from Colombia population, showing 84% of sex classification accuracy in the frontal sinus when using 2D GI method as well. However, a study from Iraq population showing lower classification accuracy of 77% as they were using linear measurement method. Sexual dimorphism of the frontal sinus can be contributed mainly by the hormonal level. So a study stated that a high testosterone level in males contribute to accelerate growth in the bones, which then contribute to a larger size and different shape of the male skeleton compared to females. And whereas the predominant estrogen in females might cause the bone to become smaller and different morphology of the bone from the males. Meanwhile, for physical activities, we can see that males engage in physical activities more than females. So, a study stated that physical activities will create a demonstrable effect on the bone, and it will cause the bone to become more osteogenic and eventually change the bone morphology. So, this will create a demonstrable difference in the bone morphology between male and female. As the conclusion, frontal sinus is a valuable tool for sex estimation as there is high accuracy of estimating a person's sex just by using 2D GM analysis on the frontal sinus. For the application, when forensic anthropologists discover any skeletal remains, they can take the frontal sinus of the unidentified disease and extrude them, and then they can apply 8 landmarks to outline the frontal sinus shape, and then they can perform the 2D geometric morphometric analysis, and the result can compare with the frontal sinus database specific to the Malaysian population, and from that they can estimate the sex of that particular unknown individual. Lastly, I would like to thank the research team of this project. We have Dr. Choi Kong from UITM as the main supervisor, and then as the co-supervisors, we have Associate Professor Dr. Spalila Alias from USIM, and then we have Associate Professor Dr. Notimajan Kau from UITM. And then we have a radiologist from UMMC, Dr. Eric, and then Dr. Halmi from SM, Ms. Rani Sakaran from AIMS University, and then Dr. Nurhanim from UITM. So these are my references. Whenever there is fragmented bones, 2D geometric morphometric analysis of frontal sinus fits the gaps. That's all from me. Thank you.